Hi. Okay, so let's finish up with Unit 1 and all these financial problems. Okay, so we ended last lecture doing annuities, and annuities are when we pay into a savings account and the bank pays us interest on the money in our savings account. Okay, it was a little bit more complicated of a formula. We also did compound interest, the more simple formula, and that's when we only put the money in one time. Okay, so compound interest one time, annuities multiple deposits. Now, what we're going to talk about today is called payout annuities, and payout annuities are when you take withdrawals, multiple withdrawals, like monthly withdrawals out of an account, kind of like a retirement account works. Okay, you get monthly withdrawals out, but your account is still earning interest. The problem is the principal, the amount of money that you're earning interest on, is going down every time. So the amount of interest you're paying goes down every month. So it gets calculated not in a positive direction, but in a negative direction. Okay. And loans work the same way, like mortgages, car loans, anything that you finance, it works the same way. So both of these situations use the exact same formula. And the formula looks similar, very similar to the annuities formula, but there's a couple of very key differences here. And the biggest one being this negative sign right here. That is a negative exponent. And how you are going to handle that on your calculator is this button right here. This is the button that you push before you enter in that negative number. Okay? We don't use the minus sign, because that means subtraction, and this means the negative of this product. These two numbers multiplied together. Okay, I just wanted to point that out because until I can figure my technology out completely, I won't have a live calculator, and so I just want to make sure that you understand. I will still be writing down calculator steps as we did in the last lecture. Let's get started. It's really just plugging and chugging at this point. Okay, so let's look at our first example here. It says after retiring, you want to be able to take $1,000 each month for a total of 20 years from your retirement date. The account earns 6% interest. How much will you need in the account to be able at the time of retirement? Now, all of these variables mean the same thing. P naught, remember, is the money before you withdraw any of it, okay? It's the money that you're earning your interest on. Remember that D is equal to the payment amount. R is equal to the rate, and remember that the rate has to be written in decimal form. K is the number of compounding periods. Remember, that's always going to be written in some sort of phrase. Oops, I forgot the 0 in there, and I don't really care. And N is the number of years. Okay, so just like we did on the last, in our last class, we're going to write down all of these variables here. So I'm going to write P naught, D, R, K, and N. And then we're just going to fill out all these values here. So it looks like our D is $1,000 each month. I just said it, each month. right? So that means K is equal to 12. We're going to do that for 20 years. And at 6% interest. And remember, you've got 6%, but we need to turn that into its decimal form because we can't do any computations when it still has the percent sign on it. All right? Okay, so let's go ahead and plug it in and chug it out here. So remember, I said in the last lecture that you must show me the setup. If your work doesn't show me this part where you have plugged everything into the formula and you simply give me the answer, I'm not going to give you full credit. Okay? It's really important that you understand and learn through this class, whether you'll ever do this formula again or not. It's important for you to learn in this class how to plug things into formulas and crank them out for your other classes that you're going to have to take. Okay. All right, and when you do that math, you get $139,580.77. Now let's get with the calculator steps. Hopefully you have your calculator with you. If you don't, pause. Go get your calculator. If you don't have one on you, you can grab a TI. If you Google up a TI 84calc.com, I think. It's an emulator. It's a free little calculator that's just right there, and you can just pull it up and squish your little window and set it there to the side, and you can have your calculator there if you'd like. So the calculator steps are this. Well, we're going to have to put in some parentheses here. Remember, we're doing a whole lot of stuff here on top, so we're going to need a set of parentheses there. And recall, every time you put a fraction in, you need to put it in its own set of parentheses so it reads it correctly. Okay, here are the steps. Open 1,000. Open 1 minus open 1 plus open 0.06 divided by 12, close, close. Here's the new symbol. Okay, that's what that key looked like that I pointed out to you. If you're not sure, go back. Go back to the last slide and take a look at where that symbol is. I'm sorry, I am going to work out having parentheses 12 times 20. I am going to work having a live calculator going. I just have to pick up another piece of equipment. That's 3 closes. So notice this actually had a close, right? We actually put a little times mark here. So close, close, close. It took 3 of them. 1, 2, 3. All that divided by open 0.06 divided by 12. Okay. And finally, now remember, there's 2 things I have to have for you to get points on your quizzes, on your homework, especially on your exams, okay? And it is, you need to fill in the formula, write it with all the numbers in the right place, and you need to write me a sentence. We will need $139,580.77 in the account before retirement. All right, cool. Let's do another one. Oh, let's not do another one. Ha ha, joking. All right. Like all other financial formulas, it's important that you're able to solve for different pieces, right? Like we did in the last lecture, we solved for P naught in that compound interest formula, and we solved for D in the annuity formula. And here we're also going to solve for D in the payout annuity formula. Remember, the difference between the annuity formula and the payout annuity formula is really, really uh, I can't think of the word. Really, really close together. Not the word, but that's what I'm trying to say. Brain not working. Let me show you real quick. Here's the annuity formula, okay? P naught is equal to D times 1 plus R over K to the N K minus 1 close over R over K. Okay, so see the difference? There's two main differences here. First off, these guys are flip-flopped, right? And the second off, there's a negative right there, okay? And I just want you to kind of, so you can relate it kind of in your brain, so it'll just kind of stick a little bit. And let me tell you not to worry. I'm going to provide formulas on the exam. You don't have to memorize any formulas in this class. I will provide you formulas on the exam. But just so you can really remember it, right? Remember, pay out annuities and loans. You're paying money out. That's minus in your pocket, right? So it's got a minus in it. Also, it's minus in your pocket. You're going to be being 1 minus all that stuff instead of all that stuff minus just a 1. So that's just a couple ways to kind of keep it a little bit straight in your head. Sometimes they're a little bit confusing for people. All right, so let me show you this. I'm not going to show the solving. I'm just going to go ahead and give it to you. That's going to be D is equal to P naught times R over K all over 1 minus 1 plus R over K to the negative NK. Okay, that whole shabam. Let's do a problem. Okay, you know you'll have $500,000 in your retirement account when you retire, and you want to be able to take monthly withdrawals from the account for 30 years, and your retirement account is earning 8% interest. How much are your payments going to be? We all want to know. Let's write this out and see what we got here. So we've got our variables, P naught, D, R, K, and N. All right, and let's fill in everything. We got $500,000. That's our P naught, because that's how much money we're starting off with. Okay. And you want to make monthly withdrawals, okay? And it doesn't seem like that's important information necessarily, but that's that K. Remember, it's going to be given to you in some sort of word that relates to time. So monthly withdrawals, okay, is going to be 12. From the account for a total of 30 years. 30, right on. And the account earns 8% interest. So 8% is equal to 0.08. All right, and so we're looking for how much, right? How much is our payment going to be? Let's see. D is equal to, let's write it in, 500,000 times 0.08 over 12. all of that over. Boy, I can't draw that line today to save my soul. 1 minus 1 plus 0.08 over 12. Close, close, to the power of negative. Don't forget the negative. Now listen, what happens if you forget the negative? If you forget the negative, you're going to get a negative answer. The whole thing is going to be a negative number as an answer. And does that make sense? That you're going to get paid a negative payment? So if you make this mistake and you forget that negative and you run this through your calculator and the answer is like negative $2,043.12, you need to think for a minute. You need to stop and use your reasoning skills and go, well, that's not a reasonable answer, because it's got to be a positive answer. Nobody gets paid a negative. If you get paid a negative, you're making a payment. You're not getting paid. Okay? So just keep that in mind. So negative, and then we have 12 times 30. Okay. So let's see, we're going to get those calculator steps going on here. Now what do we need to add? We need that one set of parentheses around the top. And we need one full additional set of parentheses around the bottom. And I already, just as habit, wrote in that set of parentheses already. Okay, so here we go. So it's going to be open. A cool half mil here, 500,000 times 0.08 divided by 12, close, close, divided by, now here we go with the bottom. 2 opens, 1 minus an open, 1 plus open, 0.08 divided by 12. Be careful here. Close, close, to the power of the negative. I'm going to still write it in red. The negative, open, 12 times 30, close, close, enter. Okay, so that is $130,397.13. And our sentence will be, we can withdraw. Oh, I wrote the wrong answer down, y'all. Woo! See, I was using my reasoning. I was like, that doesn't make sense. We can't keep on taking $130,000 a month out when we only started off with $500,000 and do that for 30 years. I mean, that doesn't make sense. No, I have not a mistake in my notes, but I had swapped a problem in my notes and I didn't notice my arrow. I need to use a highlighter, and actually I need to just fix it. But look, let me give you the right answer. The correct answer, and the answer that makes sense here, is $3,668.82. And that's kind of funny that I was just talking about reasonableness of answers, and then I made a complete error and had to use my reasoning skills to determine whether or not that answer made sense. So right there in action for you. So I couldn't be more happy with that outcome. All right, let's keep on going. So we can take payments of $3,668.82 a month. Okay, we've answered the question. All right, so loans, like I said, loans, same formula, exact same formula. Only difference is the question's going to be asked differently, right? I mean, we're going to be asking, what is your payment going to be? Or how much can you afford if you have this payment? So let's dive in. Okay. You can afford $700 a month mortgage payment, and you found a 30-year loan at 5% interest. And here's 3 questions I'm going to ask you about it. First, I want to know, how big of a loan can you afford? When I ask how big of a loan can you afford, that is what I'm asking it is, which one? Which variable do I want to know? D is what the payment is, R is what the rate is, K is how often I pay, and N is for how many years I pay. Then I'm looking for P naught here. So let's work with that one first. So let's write down our stuff. I'm going to write it up here. We've got P naught, D, R, K, N. And let's see what we got out of our information. It says we can pay $700 a month for our mortgage. We have a 5% interest. It is a monthly mortgage because mortgages and rent generally are monthly unless otherwise noted. It said that we found one for 30 years and we want to know how much can we afford. So let's solve that first. So for part A, we are going to have P naught is equal to, and here we go, 700 times 1 minus 1 plus 0.05 over 12 to the power of negative 12 times 30. Close that top. I almost did it. It's still a crappy line, but at least I didn't write over myself. Okay. Now, when you put that in the calculator, that's going to be that last answer that I gave us that was wrong. $130,397.13. Okay. Now, let me hook you up with the calculator steps. Okay. What do we need to do? Yeah, that's right. We need one set around the top because it's not just one number. It's complicated. I have already written in the set around that fraction. And don't forget one set up here just to keep everything cool. Alright, here we go. Open 700. Open 1 minus. Open 1 plus. Open 0.05 divided by 12. Close, close to the power of negative. Open 12 times 30. Close, close, close. Remember, we got 3 of them. 1, 2, 3. Divided by, open 0.05 divided by 12. Close and enter. And let's get that answer for part A written out. We can afford $130,397.13. $397.13. Okay. Now, part B says, how much will you pay the loan company? Well, that's literally finding out how much you're actually going to literally pay them. So if we've got our payments of $700 a month for 12 months times 30 years. Okay, so this is the cost per month. This is months per year. And finally, this is number of years. And when we compute that all out, it is $252,000. So yes, for your $130,000 home, you're going to pay $252,000 when it's all said and done. Mortifying, isn't it? Anyway, it is what it costs a lot of money to borrow money. Okay, so that is part B. Let me write a little sentence for that. So we will say our total payments will be worth $252,000. Okay, and then finally, our little part C here. Part C asks us how much of that was interest. Remember, to find interest, you write the amount. Let me write it this way. It's the total paid minus total borrowed. In other words, the principal. So total minus P naught. I'll even write it like that, which is total minus P naught. Okay, so let's figure that out here real quick. So we've got 252 minus 133.9713. That gives us the total amount of interest, 121,602.87. So almost the entire cost of that house. Frightening. And so we'll write total interest paid Tell me again why banks need bailouts. Oh, sorry, I won't say things like that. Total interest paid, but you should think things like that. It's going to take young people to make a change. Okay. Speaking of change, you know, my cat just won a hot dog eating contest. Outrageous. Blank page. Blank page. I thought I needed more room, but I made it all happen on that one. Just intentionally blank. Okay, so here's some hints for you for these finance problems. When you're deciding which formula to use, it's really important to identify the key words. You know, if it says loan, if it straight up says the word loan, you got it. Lock. You know what to use. If it says How much payment for this loan? Literally the word loan. You got it. Now there's other words that are synonymous with loan, like mortgage, like amortized note, financed note. These are other words that also mean loan, okay? If it's not a loan, if it doesn't literally say loan, that should be your first thing when you take a look at read the question. If it does not say loan or mortgage or something very clearly stated here, and I'm not going to try to trick you. I'm going to be straightforward with you, okay? But if it doesn't say loan, then you got to decide. And the way you decide first is it pay in? Like, are you making deposits? Or is it pay out? Are you getting payments? If you're getting payments, it's a payout annuity, and that is the same thing as a loan. Okay, so if it's a payment to you, then it is a payout annuity. If it is a payout to someone else, like a mortgage company, like the finance company, then it is a loan. Both use the same formula. If it is a one-time deposit, okay, you go to the bank, you open up a CD account, you open up an IRA, you open up an interest-bearing savings account, which you should always have interest-bearing savings accounts, even if you don't do anything more sophisticated than that. Make sure you're at least making a little bit of change off of them using your money, because when you put money in a bank, it doesn't sit there. The bank then takes that money and invests it and kind of guarantees that they will give you your money when you ask for it. This is how banking works. Anyway, so one payment, you open up an account. You're never going to put money in it ever again. Here it is. Boom. Here's $500. I'm going to save this $500 and make more money on that. That's my rainy day fund that hopefully I'll go on a vacation with or something, okay? That would be a compound interest problem. One payment, one time that you just earn interest on all the time, okay? If you're making regular deposits, like your retirement plan, okay? That's the best one. That's the best, most relatable example I can come up with. Like a retirement plan, that is an annuity. That is an annuity. That's when you add in money incrementally, meaning every month, once a year, every other month, whatever, okay? But usually it's once a month. Sometimes it's every pay period for people. They get payment into their 401k plans when they get paid, and that would be a regular deposit into their annuity. All right, if you have any questions on how to keep these guys straight, please don't hesitate to catch up with me on my office hours, okay? Okay, let's throw you a you-do here, but as I'm looking, it says you want to have $250,000 in the bank in 20 years. How much do you need to deposit each pay period every 2 weeks? Okay, so let me just remind you, because I haven't said that today. But in the last lecture, I pointed out to you that most of us get paid every 2 weeks, and every 2 weeks is K is equal to 26. It wouldn't be K is equal to 24, like twice a month, because there are the way that these 30, 31, and then that 28 or 29 falls in there actually allows you to have 2 additional pay periods a year. So it's actually K is equal to 26 to meet your retirement goal. Now, I just finished saying that a payout annuity and a regular annuity. Let's remind ourselves what I just said. And I'm saying this because I have the wrong formula here. Okay. Payout annuity is many payments, and a regular annuity is many deposits. And let's go back to the question, and it says, how much do you need to deposit each pay period? That tells us straight on that we're dealing with an annuity. And this isn't the correct formula, so I'm going to write the correct formula over here for you for the annuity. And then I'll have to work the problem, because I bet you I did not pay attention and read the problem. I probably just plugged in the numbers because that's what we were working on, and that's the formula I put up there. So do be careful, especially right now with everything going on with me. I will try to be very, very careful, but I will appreciate every ounce of humanity and grace that you can give me. Okay, not gonna cry. All right, haven't cried on one of these videos yet. Not promising it won't happen, but I'm gonna try not to. I don't like editing, so I'd just rather not cry. Okay, here we go. I want this to be a you do for you. Okay, so we're going to take about a minute and a half for you to crank this in. Okay, I'm going to write the calculator steps over here quietly while you work on it. Don't forget to write out your variables too. It is of great help. Okay, all right, so let's write it up here. So we're going to have D is equal to, remember this is the one that we're using over here, 250,000 times 0.058 over 26. All that crap over 1 plus 0.058 over 26 to the power of 26 times 20. All that minus 1, close parentheses. Let's see what it is. I'm not even trusting anything I wrote down. because it does look like I wrote it. Anyway, here we go. Okay, and we get $1,819.22. All right, so let's write our sentence here. We must deposit $1,819.22 to reach the goal. Okay, cool. Let's see what's next. Okay, so this question says a donor gives $100,000 to a college and specifies that the funds go to scholarships for the next 20 years. If the college can earn 4% interest, how much can they give in scholarships each year? All right, let's get after it. This is obviously, it's a payout, right? They are giving out funds each year. Okay, paying out. P naught D R K N. Let's fill it in here. We start out with $100,000 and we got scholarships for 20 years. The college can earn 4% interest. How much can they give each year? So what is K? Each year. Each year means annually. How many times a year is each year? 1. Yay. We don't know what that payment is. Let's knock this out. D is equal to 100,000 times 0.04 over 1. Don't even have to write the over, but yeah, that's going to make the calculator nicer. 1 minus 1 plus 0.04. Hold on 1 second. My mom's calling. Okay, all's good. All right. To close to the power of negative 20 times 1. I just write it. I know. It probably annoys you. But if you always do it the exact same way, every single time, even if it's something like a 1, you just won't forget it. It's just part of the habit. It's what you do. Right? Who cares? You plug in a 1 in your calculator. Who stinking cares? In fact, I'm not even going to plug in the 1s in the calculator, but I'm going to write them in my formula because I always do my formulas the exact same way because then it becomes kind of a habit. You don't have to think about it while you're doing it. It's just all of them go like this. The only difference is which formula do I need to choose for the situation. Okay, let's get those calculator steps here. Of course, as usual, we need this one. We don't need this one, and we already have this one, so we just need one set of parentheses added here. So it's going to be open 100,000 times 0.04 close divided by open 1 minus open 1 plus 0.04 to the power of negative 20, close, enter. All right, and that's going to give us, example 5, $7,358.18. And our sentence, they can award $73,58.18 a year in scholarships. All right. Okay. 2 more. You can afford $200 a month for a car payment. If you can get an auto loan at 8% interest for 60 months, take it for number 1. But how big of a loan can you afford? Okay. Well, let's throw down our variables here. We got P naught. We got D. We got R. We got K. We got N. Yep, all of them pretty much the exact same variables except for compound interest. Compound interest has got that P naught and the P sub N in it. That's the big difference. Okay, if you can afford $200 a month payments, there we know we got that. If you can get a loan at 8% interest, 8% interest, which is 0.08 for 5 years, how big of a loan can you afford? Now, we'll be paying $200 a month for car payments. K is 12. So let's do it here. P naught is equal to 200 times 1 minus 1 plus 0.08 over 12. Close, close to the power of negative 12 times 5. All that crap closed all over 0.08 divided by 12. And if we run that through, we get $9,863.69. Let's get our calc steps here. We're going to have to put a set of parentheses around the top. And I already have the parentheses everywhere else, so let's get it here. So we got open 200, open 1 minus, open 1 plus, open 0.08 divided by 12, close, close, to the power of negative, open 12 times 5, close, 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 remember, close, 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 divided by, now if you go to do that, close, 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 and they're all like up here, let me just show you an example. If they're all like this, 12 times 5, close, 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 you have to hit the little arrow button on the top. I wish I could go back and show you the calculator, but you have to hit this little arrow button. It's on the top right. It looks like it's where the 3 round directional buttons go. So you want to, there's these buttons. You want to hit that button, and that button will make it come down out of being in the exponent. You're just all hung up here in the exponent, okay? So if that's happening, that not all of them do that. Some of them don't do it at all, but some of them do. I just wanted to mention that. If you're having any trouble at all, you can holler at me. We can jump on and I can show you how. On a Zoom call, I can show you with a real live calculator, and you with your real live calculator. I can do all of that. So also you can go and you can see Mr. Jeff and Miss Danielle, Miss Teeny, any of those three over at the ACE. All right. Okay. And then finally, let's write our answer. We can afford a 9,863.69 car. Okay. Now, I want to remind you, since I just thought of it, of something else. I wanted to tell you that it is really important that you turn in with all of your quizzes and all of your exams, your work, your scratch work, because I give partial credit. Like if you transpose some numbers, if you forgot to move the decimal point enough spots, if you forgot one of the zeros on your number that you put in. There's many, many little mistakes that can be made with calculators. If you don't write all of your problem demonstrating to me that you know where to put all of these things appropriately, and to give me that piece and send it to me instead of just sending me the answer, then I can assess where you went wrong and give you more credit than a right or wrong answer. If you do not send me any scratch work on any of the problems, and that is for every exam that we have in this class, if you do not show me any work, then I am only going to assess it right or wrong, and I'm going to penalize you for not having any work at all. So please do keep this in mind. Even though all of this stuff is lots of the work in this class is going to be done on the calculator, lots of it, that doesn't mean that there isn't work to be shown to me. Okay, so I'm going to be very explicit and very clear with you on what my expectations are on what you're going to present to me as your work. Just like an employer would be explicit and clear to you on what they expect from you out of your work output. Okay? Remember, this is like your job. You're here in college. This is how I look at it completely. Don't get me wrong. I think this is your job 110%. Okay? So, just see, this is just like being in the classroom. I sometimes have to get on a soapbox and tell you about life and about college and about things. So, listen up, buttercups. Okay. It's one last you do problem. This is the last problem of this lecture. I know you're probably really glad, although this isn't as long as the previous lectures. So, not too bad. All right, I want this to be a you do for you. I'm going to give you about a minute and a half to knock it out. Okay, here, so we want to take out a $140,000 mortgage. The interest rate is 6%. The loan is for 30 years. How much will our monthly payments be? So let's, last one. Here we go. D is equal to 140,000 times 0.06 divided by 12. Maybe my neatest line of day, the last one. I'll take it. All right, and that answer, when we run it through there, is $839.37. And our sentence, the last sentence of the day, the monthly payments will be $839.37. All right, and I have some final thoughts for you. Compound interest, one deposit. Annuities, multiple deposits. Payout annuities, multiple payments. Loan, multiple payments. Okay? All right. Y'all have a good day.